Hello there. Thanks for joining us today. I have your resume here, and it looks like you have about 4 years of experience with Flutter. We are looking for someone who can not only write clean code, but also mentor our junior developers and help us architect some of the more complex parts of our app. To start things off, maybe you could give us a high-level overview of how you think about the Flutter widget tree and how widgets are composed in a real-world project.
Thanks for having me. I am happy to be here. When I think about the widget tree, I view it as a hierarchical blueprint of the entire user interface. In Flutter, the philosophy is that almost everything is a widget. Whether it is a structural element like a row or column, a styling element like padding, or a functional piece like a button, it all fits into this nesting structure. The tree starts at the root and branches out into children. To me, composition is the core strength of Flutter. Instead of creating one massive, complex widget that tries to do everything, I prefer to build small, single-responsibility widgets and wrap them inside others. This modular approach is what allows for a scalable codebase. It means if I need to change the alignment or the styling of a specific section, I can just wrap that component in a new widget or modify a small leaf node in the tree without risking a regression in a completely different part of the UI.
That makes sense. Now, moving into the actual mechanics, a lot of developers confuse the widget tree with the element tree. Since you have a few years under your belt, can you explain the distinction between the two and why that matters for performance?
This is a crucial point for anyone looking to optimize a Flutter app. The widget tree is essentially a lightweight configuration. Widgets are immutable. Once they are created, you cannot change their properties. If you want to change a color or a text string, you technically create a new widget. If Flutter destroyed and rebuilt the entire visual hierarchy every time a single variable changed, the performance would be terrible. That is where the element tree comes in. The element tree is the persistent manager. It acts as the link between the immutable widget and the actual render object on the screen. When a rebuild is triggered, Flutter does not just wipe the screen. It compares the new widget with the old one in the element tree. If the widget type and the key remain the same, the element simply updates the properties of the existing render object rather than creating a new one from scratch. This distinction is why Flutter can maintain 60 or 120 frames per second, even with complex animations. Updating a few properties on a render object is orders of magnitude faster than rebuilding the entire visual tree.
I like that you mentioned keys there. Since you brought up the element tree, let's talk about build context. I often see juniors struggling with what it actually is. In your experience, how should we describe build context, and how is it tied to the element tree?
I usually tell juniors that build context is essentially a handle or a reference to a specific element in the element tree. Because widgets are just blueprints that get destroyed and recreated constantly, they cannot hold a persistent state of where they are in the app. But the element tree is stable. Build context tells the framework exactly where a widget sits relative to the rest of the app. When we call something like theme, of context, or navigator, of context, we are using that context to look upward through the element tree. We are searching for the nearest ancestor that provides that specific piece of information. It allows widgets to stay decoupled. A button doesn't need to know how the theme is implemented. It just uses its context to ask the tree, hey, what is the primary color for this part of the app?
That is a great way to explain it. Let's pivot to state management and data flow. You mentioned looking up the tree. How does inherited widget work under the hood to facilitate that? And when would you use it directly versus using something like Provider or Riverpod?
Inherited widget is the underlying mechanism that makes that lookup efficient. Under the hood, when a child widget calls the dependOnInheritedWidgetOfExactType method, Flutter creates a formal link between that child and the inherited widget. The magic happens during a rebuild. If the inherited widget is updated with new data, Flutter doesn't rebuild every single widget in the subtree. Instead, it uses those registered links to notify and trigger a rebuild only for the specific widgets that are actually consuming that data. In terms of when to use it, I use inherited widget for very stable global data. Things like a theme, a localization set, or a user profile that rarely changes but is needed everywhere. However, for complex business logic or state that updates frequently, I would never use a raw inherited widget. I would use Provider or Riverpod. Those libraries are actually built on top of inherited widget, but they provide the necessary abstractions to handle state updates, dispose of resources, and manage dependencies without the boilerplate of writing your own inherited widget logic.
Speaking of data, let's talk about asynchronous operations. In a production app, you are constantly fetching data from APIs. How do you handle that, and how do you ensure the UI remains responsive?
For most asynchronous tasks, I rely on the async and await keywords. When we call an API, we mark the function as async, so the execution can be suspended without freezing the UI thread. These operations return a future, which is basically a promise that a value will arrive eventually. To bring that into the UI, my go-to is the Future Builder widget. It is very clean because it automatically handles the different states of a request. I can check if the snapshot is still loading to show a spinner, if it has data to render the list, or if it has an error to show a snack bar. But if we are talking about a professional production environment, I don't just put the API call inside the widget. I implement a repository layer. The widget calls a method in a below-C or view model, which then calls the repository. This keeps the UI logic separate from the data fetching logic, and makes it much easier to write unit tests by mocking the repository.
You mentioned the UI thread. Let's dive deeper into the threading model. Can you explain the relationship between the UI thread, the platform thread, and I/O threads? How do they communicate?
This is where a lot of people get tripped up because Dart is single-threaded. Most of the app's work, building widgets, handling animations, and processing user input, happens on the UI thread. However, Flutter has to talk to the operating system for things like battery levels or camera access. That happens on the platform thread, which is the main thread of the host OS, whether that is Android or iOS. These two threads communicate via platform channels using asynchronous messages. Now, if I have a CPU-intensive task, like parsing a 10 MB JSON file or performing image manipulation, doing that on the UI thread would cause the app to stutter or jank. To solve this, I use isolates. An isolate is not a thread in the traditional sense because it does not share memory with the main UI thread. Each isolate has its own heap. Communication happens via port-based messaging. For most of my work, I use the compute function, which abstracts the isolate creation, runs the task, and returns the result back to the UI thread without me having to manually manage the ports.
That's a very solid technical breakdown. Let's talk about those platform channels specifically. When do you find yourself needing to write a custom platform channel instead of just using a plugin from pub dev?
I always try to find a community package first because it saves time and is generally well tested. But there are times when you hit a wall. For example, if I am integrating a very specific proprietary SDK from a client's legacy system, or if I need to access a niche hardware sensor that doesn't have a supported Flutter plugin, I have to write a custom channel. The process involves creating a method channel in Dart with a unique name. Then, on the Android side, I write the corresponding handler in Kotlin, and on the iOS side, I do it in Swift. I send a message from Dart, the native side executes the hardware-level command, and then it sends the result back through the channel. It's a powerful tool, but I treat it as a last resort because it introduces native code that needs to be maintained across two different platforms.
Let's switch gears to UI performance and rendering. If you were tasked with rendering a list of 10,000 items, how would you approach that?
For large datasets, I would exclusively use the list view builder constructor. A standard list view tries to load all its children into memory at once, which would crash the app with 10,000 items. The builder constructor implements lazy loading. It only creates the widgets that are actually visible on the screen. As the user scrolls, Flutter destroys the widgets that move off screen and builds the new ones coming into view. This keeps the memory footprint low and ensures the scrolling remains smooth. If the list items are of varying heights, I might look into using a custom scroll view with a sliver list to get even more control over the scrolling physics and header effects.
Speaking of custom UI, let's talk about Custom Painter. When would you use a Custom Painter over just composing standard widgets, and what are the trade-offs?
I use Custom Painter when I need total control over every pixel. If I am building a complex data visualization, like a custom circular progress chart with gradients, or a specialized drawing tool where users can trace paths, standard widgets just aren't flexible enough. The primary advantage is that you have direct access to the Canvas API. You can draw paths, arcs, and custom shapes mathematically. This is often more performant for very complex visuals than nesting 50 different containers and opacity widgets. The downside is the loss of the automatic layout system. With a custom painter, you are working with raw coordinates. You have to manually calculate where everything goes and handle the size constraints yourself. It's more work to maintain, and if you aren't careful with the should repaint method, you can actually hurt performance by triggering too many redraws. Usually, I wrap the custom painter in a specialized widget so that the rest of the app can treat it like a normal component without worrying about the low-level drawing logic.
Let's talk about animations. If you wanted to create a complex sequence, say, an element that fades in while sliding from the left, how would you implement that?
For a sequence like that, I would use an animation controller and a tween. The animation controller handles the timing, telling the animation to run for, say, 300 milliseconds. Then I would define two tweens, one for the opacity, going from 0 to 1, and one for the offset, moving from a negative X value to 0. To tie it all together, I would use an animated builder. This ensures that only the specific parts of the UI that need to change are rebuilt during each frame of the animation, rather than rebuilding the entire page. If the animation is a simple one-off, I might use implicit animations like animated opacity or animated positioned, because they are much faster to implement. You just change a value and call setState. And Flutter handles the interpolation. But for a coordinated sequence, the explicit controller gives me the precision I need.
You mentioned setState. At your experience level, you've probably seen how setState can become a bottleneck in large apps. How do you handle state updates to prevent unnecessary rebuilds?
Exactly. Using setState at the top of a large widget tree is a recipe for performance issues. I follow the principle of pushing state as far down the tree as possible. If only a small toggle switch needs to change, I wrap that switch in its own stateful widget or use a value listenable builder. This way, the rebuild is isolated to that tiny piece of the UI, and the rest of the page remains untouched. Additionally, I make heavy use of const constructors. By marking a widget as const, I tell Flutter that this widget will never change. When the parent rebuilds, Flutter sees the const marker and completely skips the rebuild process for that child. In a large app, adding const everywhere can significantly reduce the number of elements the framework has to process.
Let's talk about code quality and maintainability. I've seen you use Dart extensions in some of your previous work. What are they, and how do they help with readability?
I find extensions incredibly useful for cleaning up business logic. Extensions allow you to add new methods to existing classes without inheriting from them. For example, I often create extensions on string to handle validation or formatting. Instead of having a utility class like string utils is valid email, I can just call email is valid email. It makes the code read more like a natural sentence and keeps the logic tied to the data it operates on. I also use them for date time to add methods like toRelativeTime, which returns strings like 2 hours ago. It moves the formatting logic out of the UI layer and into a reusable extension, which makes the widget code much cleaner.
Let's touch on a more advanced architectural pattern. How do you handle the scenario where an effect, like an API call, needs to run only when certain dependencies change, but you want to avoid infinite loops?
That is a classic challenge in reactive UI. The best approach is to implement a dependency tracking mechanism. In frameworks like React, this is what useEffect does. In Flutter, if I am using a below-C or a custom hook-like structure, I keep a reference to the previous value of the dependency. Before triggering the effect, I perform a comparison. If the current value is the same as the previous value, I simply return and do nothing. The effect only triggers if the dependency has actually changed. This is critical because if the effect itself updates the state that it depends on, you end up in an infinite loop of rebuilding and fetching. By strictly checking the value change before executing the side effect, I ensure that the API is only called when absolutely necessary.
Let's talk about testing. At your level, you should be driving the testing strategy for the team. Can you explain the difference between unit, widget, and integration tests, and when you would use each?
I view testing as a pyramid. At the base, we have unit tests. These are the fastest and most frequent. I use them to test a single function, a mapper, or a piece of business logic in isolation. If I have a function that calculates a discount, I write 10 unit tests for it to cover all edge cases. No UI is involved here. Then we have widget tests, which are often called component tests. These are used to verify that a specific widget behaves correctly. For example, if I click a button, does the loading spinner appear? Does the text change to submitted? These run in a simulated environment and are much faster than full app tests, but they give me confidence that the UI is reacting correctly to state changes. At the top, we have integration tests. These are the slowest because they run on a real device or emulator. I use these for critical user journeys, like the sign-up flow or the checkout process. It ensures that the app, the API, and the database are all communicating correctly in a real-world scenario. A healthy project should have thousands of unit tests, hundreds of widget tests, and a handful of critical integration tests.
That's a very professional approach. Let's go back to the data layer for a moment. How do you implement persistent local storage in a production app? I'm interested in how you structure it for scalability.
I choose the tool based on the data's nature. For simple things like user preferences, a dark mode toggle, or an auth token, I use shared preferences or Hive. Hive is particularly great because it is a NoSQL store and is incredibly fast. For structured data, like a cached list of products or a local message history, I use SQLite or a wrapper like Drift. But the key to scalability isn't the tool, it is the architecture. I always wrap the storage mechanism inside a repository layer. The UI never talks directly to SQLite. Instead, it talks to a product repository. This way, if we decide to switch from SQLite to another database in 6 months, I only have to change the code inside the repository. The rest of the app remains completely unaware of the change. This also makes unit testing much easier, because I can simply swap the real repository for a mock version that returns hard-coded data.
Final technical question. Let's talk about the basics of API calls. If you were mentoring a junior, how would you explain the process of making an API call and handling the response?
I would start by introducing them to the HTTP package. I'd explain that a network request is an asynchronous operation, so we must use the async and await keywords to prevent the app from freezing while we wait for the server. I would show them the flow. First we make the request. Then we check the status code. I tell them that a 200 status doesn't always mean the data is correct, so we need to validate the response. After that, we use the Dart, convert package to turn the raw JSON string into a map. Crucially, I would teach them not to use that map directly in the UI. I would show them how to create a model class and a from JSON factory method. Mapping the JSON to a typed object prevents typos throughout the app and makes the code much more robust. If the API changes a field name, we only have to change it in the model class, not in every widget that displays that data.
That covers the technical side very well. Before we wrap up, do you have any questions for us about the team or the project?
I do. I noticed that you are scaling the app quite quickly. Are you currently facing any specific performance bottlenecks or technical debt that you are hoping the new hire will help resolve? Also, how does the team handle code reviews and architectural decisions? Is it a collaborative process, or is there a lead who sets the direction?
Those are great questions. We are seeing some jank in our main dashboard as the data grows, so your experience with the element tree and isolates will be very valuable. As for the culture, we are very collaborative. We do peer reviews on every PR, and we have a weekly architecture session where we discuss new patterns. We want someone who can lead those conversations, but also listen to the team.
That sounds like a great environment. I really enjoy the collaborative aspect of architectural design.
Well, it was a pleasure talking with you. You clearly have a deep understanding of the Flutter internals and a very mature approach to app architecture. We will be in touch within the next few days regarding the next steps.
Thank you very much for your time. I look forward to hearing from you.